Alright, so a parallelogram, remember, what did we know about parallelogram? What are some things? What does parallel mean? Parallel means two lines that never intersect. Good. Okay, so parallelogram is opposite sides are parallel. So you have opposite sides that will never intersect. And we had like 5 theorems about parallelograms, 6 theorems. So find that fold board real quick. Let's go through those theorems. Alright, so go back to your fold board. What was theorem number 1 with parallelograms? Does anyone know theorem number 1 for parallelograms? Opposite sides are congruent, good, or equal. What's theorem number 2? Opposite angles are congruent. Theorem number 3 is consecutive angles are next to each other. They're not congruent. Opposite are congruent. What are the ones next to each other? The ones next to each other. Supplementary, right? Okay. And then we also know in theorem number 5, that's the other one that's kind of important. 1, 2, 3, and 5 are like their important ones. Yeah, I'm working on it. Okay, 1, 2, 3, and 5 are important ones. 5 is the one where their diagonals bisect each other. That's a really important part of this as well. Good. Okay, so it's a rhombus is a type of parallelogram where all sides are congruent. Okay, Lene, you're going to miss like all the important stuff here. Okay, go quick. All right, so we're going to glue this in. And I'm just going to glue it straight in from top to bottom. Okay, so go ahead and glue it in on one side. I'm not going to cut it at all. Just glue it in on the left side or the right side, depending on what side your paper is. And then as we work, you might want to take out 1, 2, 3, 4-ish colored pencils, maybe. That might be excessive. 3 colored pencils for sure. 4 if you want to be super fancy-dancy. Alright, so get that glued in. We didn't cut it at all, just glue it in on the left side there. Nope, there, that's that pencils. Alright, and then grab some pencils out. I'm going to use just 4 colors. Looks like I got red, purple, orange, and green today. Okay, wait till Lene gets back. Alright, so if I know that this is a rhombus, okay, DKLM is a rhombus. I'm going to write that off to the side here, DKLM. So I'm naming the outside points. is a rhombus. That means I know all sides are congruent. So what's one of the sides of this this rhombus? Who can name one of the sides you see in this rhombus? Any side. Good, DM. So DM is going to be congruent to KL. Good. To show congruent, we use what? Tick marks. Good. So DM is congruent to KL. But those are opposites, so we know for sure since it's a parallelogram, those are congruent. Well, we also know that they're all congruent. So what's another side in that rhombus? What was it? AK. That's part of the diagonal. DK. Good. And what's our fourth side? ML. Good. So all those sides are congruent to each other. Okay, now, so since it's a type of parallelogram, we know all those theorems that go with parallelograms are going to go with this rhombus. So if you're missing that foldable, that's going to be something really important to get caught up on this week and tonight. Okay? So what we know is that the diagonals are perpendicular. Diagonals are perpendicular. Who's got that vocab brain that can tell us what perpendicular means again? You guys are quiet today. Perpendicular means they intersect at 90 degrees. Good. So if you want to put that by that perpendicular at 90 degrees. So where I see my diagonals, M to K, when they go corner to corner. So M to K is one diagonal. What's another diagonal here? Good, D to L. Oops. Screwed that up a little bit. That's all right. A little rusty. Haven't done notes in a while, Miss Morrell. All right. So we have D, L, and MK are our diagonals. I color-coded those green. And I know that they're perpendicular. They intersect at 90 degrees. So what symbol can I show on my diagram here that shows 90 degrees? Square. Good, the little square. And that's going to be right at A there. It could go in any one of those four spaces. I'm going to throw it here. This little square. That means it's 90 degrees. All right, there is one other really important property of rhombi, of a rhombus, that's different than a parallelogram, and that's that the diagonals bisect the angles. All right, so bisect, what does that word bisect mean again? Sect means like parts, and bi means good, cut in the middle. Bi usually means two, so two parts that are the same, so cut in the middle. I think you just need to log out and log back in, because you didn't have a pass in here, so not okay. Alright, so if I look at angle D up here, that diagonal L to D bisects that angle. So I know this part on the top here will be the same as this part on the bottom here. Why is this not working today? I must have gotten a piece of glue right in the right spot there. Whoops. Okay. Well, that's the way it goes some days. So those two parts are congruent. They're the same because it cuts it right in the middle. So if I knew that angle D was like 100 degrees, how much would each of these smaller angles be? 50. Good. So it's 50 and 50. They're the same. And that only happens with a rhombus. In a parallelogram, that doesn't work. But with a parallelogram, we know what other angle would be the same as angle D? L. Good. The opposite. Nice. So angle L, I'm going to use the same color down here. And these will be congruent to each other. So all four of these angles are the same. They're all congruent. Okay, and then same thing happens up here with K and M. So at K, we have that bisecting. It's not the same as D and L, so instead of just using one arc, how many arcs should I use? 2. And same thing, that's same as down as angle M. We have those 2 and 2. Alright, so make sure you got your rhombus all marked up with all that information. That's going to be helpful if you get to the test next Friday. And next Friday you're looking at the test and you're like, I don't know anything about a rhombus. This has a lot of information right here that can help you with that.
Those arcs are the same color as the tick marks?
No, it's red. It's a really light red. Good question. The tick marks are supposed to be orange. These are red. I think this is a red-orange. Swell red. Color swell red. I don't know. Alright, we're going to do 4 problems here in the next 2. So try not to go to the last one at the bottom there. We're going to try and fit everything in this next little part. We have 3 examples that are going to go with this first one here. Holy moly. All right, it says A, B, C, D is a rhombus. Alright, our first one, number 1, first example. We have 4 examples today, and then we're going to just talk a little bit about squares. So we're going to stick with rhombus for a moment. Okay, if AD is 7 centimeters, I want to know what is CD. All right, so first off, let's take a look at and see where is AD. Is it on the top, the bottom, left, right? Where would you describe that on that rhombus? I'm just trying to get you guys to talk. Left. Okay, cool. It's right here, A to D. And we're saying that that is 7 centimeters. So what else do we know is going to be 7 centimeters? What other sides? Good. The one across from it will be 7. So those are congruent. What other sides will be 7?
AB.
Good. AB and CD. A rhombus is where all sides are congruent. So if I know that one side is 7, then that means all sides are 7. So how long is CD going to be? 7. 7 what? 7 meters. All right, number 2. If BD equals 4 centimeters, I want to know how much is PB. If BD is 4 centimeters, I want to know how much is PB.
2.
How'd you get 2?
It bisects in the middle.
Good, it bisects in the middle, so right at that P is a midpoint of BD. So as I look at that BD, if you want to color code, you can, just so we can take a look. We know that whole thing is 4, and the diagonals bisect each other. That's our that's part of our theorems of parallelograms. So that means P is a midpoint. So I'm going to take 4 and do what with it?
Divide by 2.
Good, divide by 2. We're going to break it into 2 parts. So 4 divided by 2 is 2. So PB is equal to 2 centimeters. Wonderful. All right, last one that goes with this one. Actually, we're going to do it in this next one. Yeah, we'll do it in this next one. We'll just do 3 examples. Is that okay with you guys? Really, this next one's going to be 4. We'll skip the next one. That's fine. All right, so now we're going to move on to this A, B, C, D, this one down here, this next one. So if you want to do a little dashed line saying that that was for that top one, now we're moving to this bottom one. All right, in this bottom rhombus, I'm really struggling with that word today, rhombus. Ugh. Can you guys imagine coming back from Puerto Rico and then the next day you have to teach about rhombus? Ooh. All right. With this rhombus, we have one angle. We have this 32 degrees. Okay, and that's angle, how would we name that angle that's 32 degrees? Good, B, A, does it go all the way down to D? E, good, it cuts across to E. It's just this top angle is 32 degrees. Okay, so we know that, and based on that, we need to find the amounts 1, 2, 3, and 4 are. 1, 2, 3, and 4 are not the angle degrees. We need to find how much those are. So that's our goal, is to find what is measure of angle 1. Remember that M, we say that as the word measure. We need to find the measure of angle 2. Measure of angle 3. And we need to find the measure of angle 4. All right, when we have numbered angles, we don't necessarily go in order. We don't have to start at number 1 and go all the way down to 4. We just numbered them. Usually when we number them, it's what looks nice. It's not necessarily about what we think through nicely. So we know that BAE, angle Bay, it's our favorite angle. We love them so much. Angle BAE is 32. So what's our next angle we could find? Angle 4, okay. Angle 4 is in the middle. That's at BEA. What do we know about our middle angles in a rhombus? Good. They are perpendicular, so they bisect each other at 90 degrees. So angle 4 is how many degrees? 90. All those middle angles are always 90 degrees in a rhombus. All right, let's talk about that 32 degrees. Where else do I know is going to be a 32 degrees? Yeah, right below it. So this would be 32 as well down below. So I have 32, 32. How much is all of angle A then? 64, good. Where else can I use that 32 degrees? Angle 3, yeah, across from it, that angle C. Remember, A and C are also the same. So at C, this top is 32 degrees. And how much is the bottom? 32 degrees. So across, these 4 are all the same. So angle 3 is going to be 32 degrees. All right, now there's a couple ways to do this next part with angle 1 and angle 2. Couple different ways to think about it. One way we can think about it is we knew that angle A was 64 degrees. A and B are next to each other. Do you remember theorem number 3 from parallelograms? Angles that are next to each other have to be what? Supplementary. They have to add up to 180. So if I knew this was all 64, I could figure out what this is going to be and then split it into 2. Or I can take a look at this and what smaller shapes are created by our diagonals here. What shape do you see there? A triangle. And we know a triangle adds up to 180. Would you guys rather work with a triangle or with a parallelogram? Cool, a triangle. You guys are amazing. All right, so many decisions are being made today. All right, I'm going to color this in just so that I can see where this came from. I'm going to redraw this picture over here. So I have B. I have B, E, and A. Let me finish this one really quick, Tuan. Let me finish this example really quick. Okay, thanks. All right, we knew A was 32 degrees. How much was at angle E in the middle there? $90, good, 'cause in the middle of our rhombus is always a right angle, so 90 degrees. And we know all together these have to add up to 180, good. So remember we can do like 32 plus 90, then subtract from 180. Or we can think just what's 180 minus 32 minus 90. What'd you get? 58. So that means angle 1 in that purple triangle, to make that a triangle, we know that this is 58 degrees. And our last one we need to find is angle 2. How much will angle 2 be? 58. Yeah. Why is angle 2 58? What was that word that we used to say that those two angles will be the same? Started with a B. Bisect. Good. It bisects it. So angle 1 and angle 2 are the same. Beautiful. Thank you, Carter. You crushed that. All right. And Adriana. You guys are amazing. Last part here. We're going to just quickly talk about squares. Squares are really boring. They just kind of have to do with everything that we've talked about so far this chapter. Okay? And you know a lot about squares already. So we're not going to do an example of the square because most examples are going to just be, I don't know, this side is 3. What's all the other sides? It's going to be like 3. All right, what do we know about squares? What are you taught when you are younger about a square? All sides are equal or congruent. And what else do we know? All angles are 90 degrees. What do we call a shape where all sides are equal? An equilateral. And what do we call a shape where all angles are equal? Angular. And if a shape is both of these things at the same time, when I combine those two things together, what do we call those special shapes that are both equilateral and equiangular? This goes back way back to Tuesday. Does anyone remember what we call those shapes where they're both equilateral and equiangular? It's way back in the Chapter 6 introduction. Starts with an R. Regular. It's a regular polygon or regular quadrilateral. Woo! All right, you guys crushed that. I know that's been a lot of days of notes.